Here we go again. Ladies and gentlemen, welcome back to the JEC World Live demonstration area. Our next demonstration will be conducted by Aerovac-Composites 1. Aerovac will show you how you can save time, money, and effort with vacuum infusion and custom process material kits. To show us this fabulous demonstration, I would like you to give a very warm welcome to our two experts, KNOX, a technical services manager from Aerovac, and James Jones, a lead technical support manager from Composites 1. Gentlemen, the demonstration floor is yours.
Joanna? Is my mic? Okay. Thank you, Joanna. Good morning, everyone, and thank you for joining our demonstration of the vacuum infusion process, highlighting custom process material kits from Aerovac. And how many people are using the vacuum infusion process now or interested? Show of hands. All right, we got a few. Yeah, the vacuum infusion process is a great process for getting very high fiber content, low emissions, and it can be used on inexpensive tooling. We'll dive into the details, but before we do that, I want to let Jim tell us a little bit about Aerovac.
Yes, thank you, James. Aerovac is a leading global supplier of vacuum bagging consumables. The materials that we're demonstrating today were manufactured and prepared in our film plant in Mondovì, Italy. We also have a facility in Toulouse, France, where we do kitting, primarily for aerospace. And we also have operations in the UK, in the USA, in Salt Lake City, and in Brazil, so that we can get our vacuum bagging consumable solution to you wherever you are globally.
Thank you, Jim. Yeah, the vacuum infusion process is a very simple concept. We can get very high strength, lightweight parts in a low emission process. It's used in many different industries, including marine, wind energy, aerospace, and industrial applications. We can scale the process up to very large parts. In a lot of cases, we've done parts up to 3,000 square meters. With over 10 tons of resin being injected. So like I said, it's very simple. We just load the dry fibers into the mold. We seal them under a vacuum bag and inject the resin. It's really easy, right? Well, the devil's in the details. So we'll show you back here on our demonstration some of the details and how the process materials can really make the process much easier. So we have a very simple mold. We just have a tempered glass plate. For the mold requirements for vacuum infusion, it just needs to be airtight. In a lot of cases, the flange on a vacuum infusion mold needs to be about 150 millimeters. We're working with about 50 millimeters here, and we'll explain that a little bit later in the process, how we're able to do that. But we've loaded all our, in this case, we're using fiberglass multi-axial fabrics. We could be using carbon fiber or Kevlar, any type of reinforcement, really. And we also have a closed-cell PVC foam core, and we're going to be infusing a integrated stiffener. So we have a polyurethane core as a form, covered with multi-axial fiberglass. So since we're loading all the glass fibers in dry, we need something to hold it in place. So we're using a tackifier product from Aerovac called Aerofix 3. It's custom formulated for the infusion process. It's compatible with polyester, vinyl ester, and epoxy resins. And it's available, in this case, it's a red tint, so you can see how much material you're applying. It's also available in a blue tint and a high-tack version. We also use a different material. This is a glass fiber mesh tape with adhesive backing, and it can be used in the laminate to place materials in specific places. And since it is glass, it doesn't compromise the laminate integrity. So with the dry fiber preforms, especially the multi-axial fiberglass and carbon fiber, those are very low permeability materials. That means the resin has a hard time getting through them. So what we do in the infusion process is we use a very high permeability material on top of the laminate, and the resin races across the top and then down through the thickness. In this case, we have two of those products. It's a flow media product combined with a perforated release film. So it's a combination product. We can add a high permeability layer on top of the laminate. It's easy to apply and very easy to release. So we have two different products. We have the blue one is the Infuply 2. It's a knitted mesh combined with a perforated release film. It's very conformable and conforms to various shapes on the mold. It's very soft. We also have an extruded mesh that's a little bit stiffer. It flows a little bit faster than the Infuply 2. And it's good for parts with very gentle contours or flat parts. So also to get the resin into the part, we're going to be injecting with the machine over here, and the resin's going to come through the tubing. And under the bag, we also have another product called CW5. And this is our resin channel, essentially. And it runs along the length of the edge of the part. This infusion setup is symmetric. We're going to be flowing from where Jim's standing and from where I'm standing to the center of the part. And this allows the resin to distribute very quickly to the edges of the part, so we can get a very nice, even flow front across the part to the center. If we can zoom in on this piece. So this CW5 is basically a corrugated mesh inside of a polyester sleeve. And so the resin can flow very fast through there. It's about 4 or 5 millimeters thick, 50 millimeters wide, and then the resin flows out from there. This product's very nice because it lays very flat on the part, so we're not going to get any imprint once the resin cures. It's very easy to apply and very easy to release. It needs to be in direct contact with our flow media, and you can see that that's the case here. So I think we're about ready to inject. So what we're going to do is we're going to be able to show you, since we're on a glass plate, this is a very good mold for doing testing because you can see the flow on the top and the bottom. So we're going to be able to show you that here today. So MVP is helping us out with their Innovator 2 injection machine. We have our resin dialed in, and we're ready to inject. So if we can switch to the split screen, maybe. So on the left, you can see the underside of the mold. Since we have a clear glass plate, we actually have a peel ply against the glass plate. We have an 1150 GSM quadraxial. And then, so we can see the resin flowing on top on the right side through the Infuply 2 and the Infuply 3. And then you'll see it also on the underside. Yeah, now you can see it coming through the bottom. So you can see testing on a glass plate is very useful because there's a lag. We're flowing much faster across the top in the high permeability area than we are on the bottom. And the core we're using is a closed cell foam, so it has to have perforation holes about every 20 millimeters. And it also has grooves against the mold side. So you can see the difference in flow rate between the Infuply 2 and the Infuply 3. Faster is not always better, especially when dealing with fibers like carbon fiber that have a much smaller fiber diameter. We want to infuse those slowly so we get them completely saturated, so we can get all of the properties out of the fibers. So the resin we're using is a vinyl ester resin formulated specifically for infusion. It's low viscosity and no thixotropes. Viscosity is in the range of 140 to 180 centipoise. And today we're working with about a 30-minute gel time. One of the things you'll notice, we'll get a shot of this here. We don't bring our flow media all the way up to our vacuum. We stop it about 50 or 75 millimeters short. And so what we want to do is, since we have that lag from the top to bottom, we want the resin to have a chance to catch up and our flow front to be even on the top and bottom. So I mentioned earlier that we're able to use almost the entire mold surface. We only need a small flange to adhere our sealant tape because we're pulling our vacuum directly on the part. And that's a unique product that we're using. It's called VMS3. And it is a multi-layer product. It combines a perforated release film that goes down against the laminate so the resin will not stick to it. And then directly on top of that is a semi-permeable membrane. The semi-permeable membrane allows air to pass through, but it will not allow liquids to pass through, so the resin will stop. Then we have an air breather net inside, covered finally by a vacuum film. And so that is a really nice product. We can put it directly on our laminate without any risk of drawing out resin or creating dry spots. So this configuration is kind of a simulation of, say, a large deck panel or a floor or a bulkhead. We would have about 1.5 meters between these stiffeners, and we could scale this up to, we've done parts up to 100 meters long by 30 meters wide. Same concept, just a larger process, all injected at one time. So the VMS3 is very good for applications like this on top of stiffeners. We can also use it like in wind energy where we have laminate transitions from a very thin skin sandwich structure to a very thick skin, solid, monolithic glass structure. And so once the resin hits it, it's still pulling vacuum, so we don't close off our vacuum. So I'm going to let Ferruccio show you how we configure the VMS3 in the infusion process. The VMS3, Jim, do you have that roll? Or the roll's here. So the VMS3 comes on a 100-meter long roll. You can cut it to any length you like for your part. In this case, we're just going the length of the stiffener. So you can see the first thing Ferruccio is going to do is cut a small hole in the vacuum film on top of the VMS3. We don't want to cut through the mesh, just through the vacuum film. Then he has a resin connector that connects to our hose, and he's going to seal that to the VMS3 with the sealant tape. In this case, it's the LTS 90 sealant tape from Aerovac. This just makes sure we have an airtight seal on top of the VMS3 so we don't get any resin coming over the top and into our mesh. So he sealed the connector. Now the next thing we need to do is seal the ends of the VMS3 so that we don't get any resin coming into the end. So we have a specialized form of the LTS 90 that's thinner and wider. So he just seals the bottom and trims it, and then he'll fold it over to seal the end. So our infusion is complete now. We've put all the resin into the part, and you'll notice the VMS3 is not drawing any resin out of the part. If we can get another shot of the bottom of the panel. We can take a look at the bottom of the panel to see. It looks like everything's saturated on the bottom of the panel as well. We have glass in between the stiffener and the panel. Let's grab this. This is the part we made yesterday. If we can get a shot of this. You can see we have very, very thin skins. We just have a 1150 GSM quadraxial on both sides of the core material. And then we've added some material as a pad layer underneath the stiffener. But you can see everything is completely saturated under the stiffener, against the mold surface, and on the stiffener itself. We've actually added additional glass on the cap of the stiffener to give it more strength. But everything is completely saturated, and we don't have any resin being drawn out of the laminate. So I'll go ahead and let Jim tell us a little bit about the vacuum film we're using, the sealant tape, and the custom kits.
Yes, thank you, James. So what we're demonstrating today in terms of the vacuum film and the sealant tape is a great general purpose material. This is StretchVac 4000. It is a vacuum bagging film that works fantastic for low temperature infusions all the way up to 214C autoclave cures. Likewise, the sealant tape, our VacSeal 2042, it's nice and tacky, performs well at room temperature, and is also good for the 204C cures. So, if you're making a lot of different types of parts or different cure temperatures in your shop, these are two all-purpose materials you can have to kind of handle everything. We do have a full line. So if you're only doing low exotherm infusions, we have our 200G vacuum bagging film that's good for 120C. And then we have, products with every cure temperature in between and then above for thermoplastics as well. And in terms of sealant tape, again, this is a great general purpose one. We have LTS 90 that he showed sealing. The VMS 3 that is a nice lower temperature sealant tape for infusion applications.
Yeah, and with the custom kits, in the infusion process, you want the vacuum bag to be about 25 to 30% larger than your part. And then we take up that extra material in pleats because we don't want to have any bag bridging where we're going to get big masses of resin that will cause a large exotherm. The stiffener requires a little bit more bagging material so that our bag will completely conform. We don't want to. The bag has a very high elongation, but we don't want to rely on the elongation of the bag. So we take up the extra material in pleats. With the kitting process, we're able to include the pleats. So this bag had the pleats included along the long edges, and then it had the pleat areas marked on the short edges so that the pleats are in the exact same location on every part. So there's no guesswork. If you have an operator that doesn't show up one day, whoever's making the bag is going to make it the same way every time. We are also able to mark our locations for our resin inlets and our vacuum outlets. So anything you want marked on the bag or even the flow media, we can mark where the resin lines need to go and where the VMS3 will be placed. So there's no guesswork.
Yes. All of the materials we're demonstrating today are available conventionally as roll stock. But as James is saying, we also offer kitting services. For many customers, they prefer this. We can prepare the materials for you and cut them custom to the exact shape of your part, including even pre-pleating. And usually, customers find they can bag a part up in about 1/3 the time using kitted materials.
Yep. So we can show you the underside of the mold again. So you can see the get a shot of this? That everything's completely saturated. So the glass becomes transparent and the peel ply, so we can actually see the core material through the fiberglass. So there's the infusion process is very good. As I mentioned, we can get fiber volume fractions approaching 50%. Fiber weight fraction for fiberglass is in the range of 70%. And very low porosity. Since everything's under vacuum, we have plenty of time. We're not relying on the gel time of the resin. We can make sure that our vacuum bag is sealed perfectly before we ever mix the resin or start the injection process.
And just to reiterate a couple of the impactful process materials here, the InfoPly tube, it's very conformable. It'll go over contoured parts. It's a 2-in-1. It's a self-releasing flow media, so it's very easy and convenient to use. And again, our VMS3 that we're using for our vacuum line, it has a lot of advantages. You can put it right on the laminate surface with no mark off. You can place it in an area that is difficult for the resin to reach. Maybe it's a thicker area. It's a feature to ensure that you fully wet that out, and then it strips away cleanly and easily at the end of the infusion process.
So you can see the vacuum infusion process is very easy to implement, especially when you have the right materials. So I guess with that, do we have any questions? Any questions?
Ladies and gentlemen, don't hesitate to pose any questions, to ask any questions that you have. We have microphones, even in the back if you have questions. Any questions over here, gentlemen? You have 3 experts. Okay, I have a couple of questions for you then, gentlemen. Can you tell me what type of part infusions most benefit from using the VMS3?
Yeah, so the VMS3, like we talked about, it's a multi-layer vacuum line that can be placed directly on the laminate. So like the part we're doing here today, it's very good on top of stiffeners in areas with laminate transitions from very thick laminates to very thin laminates where you get differential flow. It's very good. If you have areas that you have trouble spots that you normally get closeouts, you can place the VMS3 in that location, and it will get rid of the closeout, and it won't pull any resin out of the part.
Okay, thank you very much. One more question for you. Do you have any other combination products available besides VMS3 and InfuPly 2?
We do. Jim?
Yes, we offer a full line of combination products. We find it's quite convenient for our customers. It solves problems for them. A couple I'll highlight. With the InfuPly 2 and 3, we also offer a product we call Combi 1, which is the same product but with peel ply added if you need the surface characteristics that you get from peel ply. Also in the VMS line, we have VMS 4, where we remove the release film from the bottom of the combination product if you don't need the release characteristics. And if you have other combination product needs, we would love to talk to you about it and see if we could help you.
Okay, fantastic. So thank you so much, Jim and James from Aerovac. And ladies and gentlemen, they will be back again here today at 2:45. Don't hesitate to ask them questions this morning. Otherwise, you can visit them at their stand 5H13 if you would like to meet them, as well as the rest of the Aerovac team. Thank you very much. We wish you a lovely day at the show. And ladies and gentlemen, our next live demonstration will happen in just 15 minutes with Rock Tool. Don't hesitate. It's happening here live at the demonstration area, and we would love to see you back here in 15 minutes.